Hello, everyone. It's my honor to introduce our work to you. Our paper is called Nearly Multiscale Correlations for Human Motion Prediction. Human motion prediction aims to use the 3D skeleton data to predict a sequence of future human motions based on observed motion frames. It plays a significant role in robotics, computer graphics, healthcare, and public safety, and so on. And from the related works, we discovered the importance of human body correlations on human motion prediction tasks. We keep under observation on motion rules for the real person. Found that in the actions like running, the core movement mainly exists among the big limbs, while in some other actions like smoking, the small movement of the wrist or elbow could lead to really different future poses. So this scalable attention of human motions inspires us to capture the correlations of human body in a multi-scale way. So we make a comprehensive study on human motion prediction and propose an encoder-decoder framework called the Multiscale Graph Convolution Network, or MGCN, to deeply exploit the correlation of human body joints and components in the multi-scale graphs, which is action agnostic and end-to-end. We also verify the effectiveness of MGCN on true benchmark datasets, especially. Our approach outperforms the SOTA method 5 to 7 millimeters for the long-term prediction, which is a big lift. And to capture the correlations, we need the multi-scale graphs. According to the law of human body movements, the skeleton joints of the human body are aggregated in different scales to form multi-scale human body graphs. Okay, now let's have an overview of our model. First is the DCT, discrete cosine transformation. DCT is used to capture a temporal dependency. The second is a scale transformation module, or STM. It is used to form multi-scale graphs. And then is the scale interaction module. It is used to capture the human body correlations in and across graphs in different scales, and the SIM can be stacked for n times. And finally, is the 3GC layers. It is used to exploit features in consideration of scale differences. Okay, next we will introduce the modules in details. First is the scale interaction module. It is composed of GCN and cross scale block. A GCN is a fully collected GCN. It contains 6 GC layers with residual collections. And with the GCN, we can exploit the human body correlations in scales. The second is a cross-scale block. It can exploit the human body correlations across the scales. The CSB uses the output feature H of MLPs to calculate a weight matrix A, and uses A to update the features of GCN by this formula. And the second module is Scale Transformation Module, or STM. The STM is composed of several MLPs. We use the two-layer MLPs to aggregate two joints into a component as a graph joint at a larger scale. So, by the STM, two joint becomes one joint in the larger scale. And the second module is the cross-to-fan decoder. The outputs of graphs in different scales are fed into the decoder in a cross-to-fan order. The reason is that the features in larger scales will provide more coarse information to generate graph poses, and the features in smaller scales can further optimize the poses. And then we will report our experiment results. We make experiments on the human 3.6M dataset and into a matrix, the mean angle error or MAE, and the mean per joint position error or MPJPE. From the table, we can say that in the average column, we achieve the best performance. And this table is the long-term prediction in MPJP on human 3.6M. We also achieve the best performance. And our advantage is bigger in the case of long-term prediction. We just make a prediction in 1000 milliseconds. And this table is the short and long-term prediction in MPJP on CMU vocab dataset. And in this dataset, we also have a good performance. Just look at the average column. We have the best results on all 10 steps. And finally, we also made the ablation study. We can see from the table that without any of the three model components, it means without STM or CSB or cross-to-fan decoder, without any of the three model components will have a worse performance, just like the table. With all the modules, we achieve the best performance. Okay, that's all. Thank you for listening.